Welcome to the Survey of Mathematics. This is lesson 1.5 where we're going to be talking about greatest common factor and least common multiple. We'll begin our lesson today by discussing the greatest common factor. The greatest common factor is the largest number that can be a factor of a given set of numbers. Let's say we have the numbers 26 and 39. What is the largest number that I could divide both the numbers 26 and 39 and come up with a whole number? The answer to that is 13. If I take 26 and I divide by 13, I get 2. So 26 is a multiple of 13. So 13 is a factor of 26. If I divide 39 by 13, I get the number 3. So that means 39 is also a multiple of 13, or 13 is a factor of 39. And we want the largest number that is a factor of both. Now, you can do this by trial and error. When you're dealing with smaller numbers and a small group of numbers, that tends to work fairly well. However, as your numbers get larger and larger, or the number of values that you're trying to find common factors for increases, that also becomes increasingly more difficult. So I'm going to show you a method today that you can do every single time and get the right answer. This is found by factoring each number into primes. Now, in a previous lesson we talked about prime factoring. We are now going to use prime factoring to help us solve today's situations. So if we were to prime factor 26, I begin by dividing by 2 the smallest prime number. Since 26 is even, it is divisible by 2. And when I do that, I get 13. Well, 13 is also a prime number, so when I prime factor 26, I simply have 2 and 13. Now if I prime factor my second number, the 39, it's not divisible by 2, but it is divisible by 3. So if I divide by 3, I get 13. Now I look at any of those factors that are common to both. Well, I have a 2 in my first number, but not as a factor in my second number. So 2 is not common. However, the 13 is common to both. Therefore, 13 is my greatest common factor because that's the only factor that's common, other than, of course, 1. If we try the numbers 72 and 180, we get a common factor that is 36. That is the greatest common factor. Now, how do we get that number? Well, we can write out factors of 72 and factors of 180, and we will see in that list that 36 is the common factor that is the highest value. But that can take a lot of time. So instead, what we're going to do is we're going to prime factor 72 and 180. If I prime factor 72, I can divide by 2 and gives me 36. If I divide by 2, that gives me 18. Dividing by 2, that gives me 9. Dividing by 3 gives me 3. So my factors of 72 are 3 2s and 2 3s. We can write it either out in the long form or in the shortened form using exponents. If we prime factor 180, well, I can divide by 2, that gives me 90. I can divide by 2 again, giving me 45. I can then divide by 3, giving me 15, and then divide by 3 again, giving me 5. So if I prime factor that, I get 2 2s, 2 3s, and a 5. So now what I'm going to do is I'm going to look at everything that is common, even repeated numbers that are common. So I look here and I see that I have a 2 in both of those numbers. I have a second 2 that is common to both of those numbers. I do not have a third 2, however. Even though 72 has 3 factors of 2, 180 only has 2. So I can only take the 2 that is common to both. Now I go with my 3s. Well, I have a common factor of 3 here, another one right here, and then I do have a 5 in my second number, but not in my first. So it's not common to both, so I cannot take both. Now if I look at all the numbers that I have circled, I have a 2, a set of 2s, another set of 2s, a set of 3s, and another set of 3s. So if I multiply those values together, the 2 times 2 times 3 times 3, I get my greatest common factor of 36. Now, as a little double check, what I can do is I can take 72 and I divide by 36, and what number do I come up with? I come up with this 2 right here. The only value that I didn't have as a common factor. If I take my 180 and I divide by the 36, if I look through my list, I get a 5. So the 5 is the only factor that wasn't common to both numbers. So that's just a little double check that I can do and that you can do as well to make sure that you do have indeed the greatest common factor. So what is the greatest common factor between 3 and 9? Well, I'm starting you off easy. 3 obviously is already a prime number, so the only factor it has is 3 as far as primes are concerned. For the number 9, it is 3 times 3, so we have 2 sets of 3's there. So the only common factor other than 1 is a 3. Just one 3. If I take 3 and divide by 3, I get 1. If I take 9 and divide by 3, I get 3. So 3 is my greatest common factor between 3 and 9. What about 10 and 35? Now again, these are smaller numbers, so many of you probably can just say, well, I already know what the common factor is. It's 5, Mr. Pletcher. Well, that could be true, but we are going to go through the process anyway, because eventually you will have harder and harder numbers. So if I prime factor 10, I get factors of 2 and 5. If I prime factor 35, I get prime factors of 5 and 7. So what is the only one that is common? The only common factor there that I have listed is the 5. So my greatest common factor between 10 and 35 is 5. What about the common factor between 7 and 10? Well, 7 is a prime number. If I prime factor 10, I get 2 and 5. So I don't have any prime factors that are common to both. So what does that indicate to me? It indicates that the only factor is the factor of all numbers, and that is 1. So my greatest common factor is 1. So if you have two numbers that don't have any common prime factors, the greatest common factor is simply 1. So what about the greatest common factor between 140 and 525? Much larger numbers that we're dealing with, but yet we're going to follow the same process. So if I start off with the 140 number and I prime factor, well, I can divide by 2, that gives me 70. I divide by 2 again, that gives me 35. I divide by 5 and that gives me 7. So prime factoring 140 gives me 2 times 2 times 5 times 7. Then I go to my 525. Now it is not divisible by 2, so I'm going to go ahead and start with the next one. Probably many of you can see that it's divisible by 5, so that's likely where you would start. When you do that, you end up getting 105. You divide by 5 again, that gives you 21. You divide by 3 and that gives you 7. I'm going to go ahead and put those prime factors in order. So we have 3 times 5 times 5 times 7 when I prime factor my 525. So now I look through what primes are common. Well, up here I have a couple of 2's, but I don't have any 2's in my second number. I go to the 5's. I do have a 5 in common to both. Then I look for other numbers. Here I have a 7, down here I have a 7, so I have a 7 that's common to both. Those are the only prime factors that are common, so I take those prime factors and I multiply them together. 5 times 7 is 35. Again, if I take my original number of 140 and I divide by 35, I end up getting a factor of 4. Well, 2 times 2 is 4, so the only factors that I didn't use to find my common factor is a total, when I multiply them together, of whatever my value is, or my quotient, when I divide my original number by my greatest common factor. If I take the 525 and I divide by 35, I'm going to end up getting 15. Well, if I take the two remaining factors that I did not use to find my greatest common factor, the 3 and the 5, and I multiply them together, I get 15. Alright, so now that we know how to do greatest common factor, let's go to least common multiple. Least common multiple is kind of the opposite of the greatest common factor. With the greatest common factor, we're looking for a factor that if I were to divide each of my numbers by, I would come up with a whole number, and I want the biggest number possible. With least common multiple, I want the smallest number possible that all of my numbers are a common factor of. So, as an example, numbers 26 and 39. What is the smallest number that I can get that if I were to divide that number by 26 and by 39, I would come up with a whole number? So if we think about the multiples of 26, well, I could have 26, 52, 78, and so on. If I tried 39, I would have 39, 78, and so on. So the least common multiple of 26 and 39 is indeed the 78 number. You could start out by listing all the multiples, but if we have larger numbers, the least common multiple may be in the thousands, even the millions. And that can take a very long time writing out all these numbers to try to find the least common multiple. So the faster way is to go ahead and do the prime factoring. We have 26, which we already worked out, is 2 and 13. And we have 39, which is 3 and 13. Now, finding the least common multiple, we're going to go about things a little bit differently. We start out by prime factoring, but that's really where the commonality between greatest common factor and least common multiple ends. What we now have to do is we are going to find out what are all possible factors that go into my number. If I take a look, I have a 2 up here, but I don't have a 2 down in the bottom. So what I need to do is I need to take whatever I can from one set of numbers. So if I'm looking at a 2, I can either take 1 2 or 0 2s. Well, I'm going to take the 1 2 from the first number. So I'm going to just circle that 2. Then I take a look at 3s. Well, I can take 0 3s if I go with the top number, or I can take 1 3 if I take it from the bottom number. Well, I'm going to take the 3 from the bottom number. Now I go to the next factor that I have, which is 13. Well, I can take 1 13 if I grab it from the top, or I can take 1 13 if I grab it from the bottom number. So it doesn't really matter which one I grab it from, I just need to grab it from somewhere. So I'm just going to take it from the top number. So here I have 2, 3, and 13. Multiplying all those numbers together, I get the common factor of 78. So the least common multiple of 26 and 39 is 78. Still a little confused? That's okay. Let's keep on moving and we'll look at another example. Let's say I work out 72 and 180. Now we did these numbers before, so I've gone ahead and prime factored them. So with 72 we have 2 times 2 times 2 times 3 times 3. For 180 we have 2 times 2 times 3 times 3 times 5. Now in this particular case it might be helpful to look at the exponent form of our prime factorization because I want to grab as many from one set of numbers as I can. So if I look at my 2's, I can grab 3 2's if I take it from the 72, or only 2 2's if I grab it from the 180. I want as much as I can, so I'm going to grab 3 2's from the 72. Then I go to my next number, which is a 3. I can grab 2 3's or 2 3's. Well, it doesn't really matter which one I do, so I'm just going to take the 2 3's from here. And then I go to my next number, which is the number 5. I can take 0 5's or 1 5. Well, I want to grab as many as I can, so I'm going to take the 5 from the 180. Now, if I multiply all those numbers together, I have 2 cubed, which is 8, times 3 squared, which is 9, times 5. That gives me a total of 360. So if I were to write out the multiples of 72, so 72, 144, 216, 288, and then 360. And then if I were to write out the multiples of 180, it would give me 180, 360, that one was kind of fast. The 360 is the lowest multiple that I have for both of those numbers. Now, let me point out one little helpful tip as you're working these out. You'll notice that I could have taken the 3 from my red number as opposed to my blue number. I chose to do the blue number because in doing so, I grabbed all of my numbers from the 72, which means when I multiply all those out, I know I have 72 already. It saves me a little bit of time in my math portion in the multiplication process. Then I can just multiply that 72, since I grabbed all the factors from the 72, times the 5. Well, 72 times 5 gives me the 360. So again, it's not crucial that you do something like that, but when you see those type of things, it may help you save just a few seconds of your time. And over a course of doing many of these, that could really add up. Let's try another example. Here I have 5 and 10. Again, we've already prime factored these. 5 is a prime number, and 10, the factors are 2 and 5. I do have a set of 5s. It doesn't matter whether I take the 5 from the first or the second number. And then I only have the 1, 2, so I've got to grab it from the second number. Well, that gives me 2 times 5, which means my least common multiple is one of the numbers that I have, the 10. Now, the least common multiple, if you do have as one of your numbers, the number that it has to be would have to be the largest of the numbers. So you're not going to have a least common multiple smaller than your largest number. Let's try 12 and 28. If I prime factor 12, we get 2 times 2 times 3. If I prime factor 28, I get 2 times 2 times 7. So the lowest common multiple between 12 and 28, if I prime factor, I want to grab as many of each number as I can, but I can only grab it from one group. So I can take 2 2's from the 12 or 2 2's from the 28. I'm just going to grab them from the 12. Then I go with my 3's. I can grab 1 3 if I grab it from the 12, but there are no 3's in the 28. So I'm going to grab the 3 from the 12. Then I go to the next number, which is 7. Well, I can grab 0 if I go from the 12, or I can grab 1 from the 28. So I'm going to grab 1 from the 28. In doing so, I now look at all the numbers that I have circled on my screen, and I'm going to multiply all of those together. So I have 2 times 2 times 3 times 7, which gives me a total of 84. So my least common multiple is 84. Again, if I wrote out the multiples of 12, being 12, 24, 36, 48, 60, 72, and then 84, and then I wrote out the multiples of 28, which would be 28, 56, and then 84. 84 is the lowest number that I get to that is a common multiple to both of the 12 and the 28 numbers. Let's try 36 and 60. So if I prime factor 36, I get 2 times 2 times 3 times 3. If I prime factor 60, I get 2 times 2 times 3 times 5. So taking the most out of each group that I possibly can, I can take 2 2's or I can take 2 2's. So I need to grab 2 2's from one of the two areas. I'm going to grab it from the top number. Now I go on with my 3's. I can grab 2 3's from my top number or 1 3 from the bottom number. So I need to take the 2 3's from the top number. And then I go with the 5's. I can grab 0 5's or 1 5, so I'm going to grab the 5 from the 60. When I multiply all those numbers together, I end up getting 180 as my answer. So 180 is the least common multiple that goes from 36 and 60. Let's try the least common multiple now of 3 numbers. Let's say I have 15, 32, and 55. Well, I start out the same way. I'm going to prime factor each of those numbers. So if I prime factor 15, I get 3 and 5. If I prime factor 32, I end up getting 2 to the 5th power. And if I prime factor 55, I get 5 and 11. I'm going to follow the same process, but now I need to look at 3 different locations rather than just 2 to get my numbers. So I can grab 0 2s, 5 2s, or 0 2s. I am going to grab the 2s from this middle number. There are 5 of them. Now I go with the 3s. I can grab 1 3, 0 3s, or 0 3s. So I need to grab the 3 from the only location it is, and which is the 15. Then I go to my 5s. I can grab 1 5 or 1 5. It doesn't really matter which location I grab it from. I'm just going to grab it from the top number here. And then I go to my next number, which is that of 11. I can grab 0, 0, or 1, so I'm going to grab the 11 from the bottom. Now if I take all those numbers that are circled and I multiply them together, I will get my least common multiple. Now if you do notice that I've got all the numbers from my 15 circled and all the numbers from my 32 circled. So rather than taking this number and this number, well, this is 32 and this is 15. So I can simply say 32 times 15, and then all I have to do is multiply by 11. Again, that saves me a little bit of work, a little bit of hassle, because I've already done the multiplication for those two and the fact that they are the original numbers. Multiply all those out. My least common multiple of all of those is 5,280. So as a quick review, when you're looking for the greatest common factor or the least common multiple, you're going to start out by prime factoring. With the greatest common factor, you want to look at any prime numbers that are located in all of your numbers and grab as many as you can from each one that is common. Multiply those together, you get the greatest common factor. If there are no common prime factors, then your greatest common factor is simply 1. With least common multiple, you're going to be starting by prime factoring, but in this case you're going to grab as many of a particular number as you can, but you can only grab that particular number from one set of your prime factors. But you want to grab as much as you can, multiply all those together, and you get the least common multiple.